Okay, so question number 7. What is the Lewis structure for CO3 2-, which is our carbonate ion? So first, let's calculate the total number of valence electrons. So carbon has 4 valence electrons. Oxygen has 6. And there are 3 oxygen atoms, so we multiply that by 3. And also the overall charge of this ion is -2. So we're going to add an additional 2 electrons to our count. And you should end up with a total of 24 valence electrons. So now let's draw carbon as our central atom. And if we were to draw 3 single bonded oxygens, you'll notice that the carbon doesn't have a full octet yet. So I'm going to make one of them have a double bond. So now let's fill in all of the lone pairs on our oxygens and count out how many electrons I've drawn in the structure. So each bond contains 2 bonding electrons, and we end up with a total of 24 electrons for this structure. So it looks correct, but to double check, we can calculate the formal charge of each of the atoms just to see if the sum of the formal charges is going to equal -2, since the overall ion has a -2 charge. So the equation for formal charge is equal to the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. Okay, so first let's calculate the formal charge of our carbon atom. So carbon has 4 valence electrons. There are no lone pairs on the carbon, so we just write 0 for non-bonding. And there are 4 bonds to the carbon, so there are 8 bonded electrons in total, divided by 2. So the carbon has a 0 formal charge. So now let's calculate the formal charge of our oxygen that is double bonded. Oxygen has 6 valence electrons, and this double bonded oxygen has 4 non-bonding electrons. And it has the double bond, so there are 4 bonding electrons in total, divided by 2. So our double bonded oxygen has a formal charge of 0. And now let's calculate the formal charge of our 2 single bonded oxygens. So they have 6 valence electrons and 6 non-bonding electrons. And they both have the single bond. So there are 2 bonding electrons divided by 2. So 6 minus 6 minus 1 is -1. So we can show that these 2 oxygens will have a formal charge of -1. And again, if we added up the formal charges, we have an overall charge of -2 for this ion. So this is expected. So we know that this is the correct Lewis structure for the carbonate ion. So the junior tutor said that a Lewis dot structure is a representation of an atom, ion, or compound that shows how the valence electrons of the atoms are distributed as bonds, lone pairs, and sometimes radicals. So they have a nice step-by-step guide. Determine the central atom. Yep. logically arrange them, connect them, and then check if the following rules are followed, not make necessary adjustments, and then you might need to redraw the entire molecule, but hopefully you can just try to get it right the first time. And for the rules, make sure that the atoms that follow the octet state strictly have 8 electrons. So this is like carbon, it needs to have 8 valence electrons. You can't form like 5 bonds with carbon. Rule number 2, minimize formal charges of the atoms if possible. So we knew we couldn't really do that with ours because it needs to have a charge of -2. More electronegative atoms are given the more negative formal charge if applicable. Yep, so we can double check with ours. Oxygen is more electronegative than the carbon, so they also carry the more negative formal charge, which is good. Make sure the sum of the formal charges match the charge of the compound. So in our case, they do. And I think now the junior tutor shows all the steps to their answer. Okay, they have the equation for formal charge. And they have the final correct Lewis structure. So this solution is correct.